Today's lesson is going to be about histograms, and it's going to be from lesson 1.3 in your textbook that's called Creating and Using Histograms. I want to start with a little definition about histograms. A histogram is going to be a distribution, and that's a function whose values are frequencies or relative frequencies. Those are like what we studied last time when we were looking at the gift card problem, where we had the number of $5 gift cards, the number of $50 gift cards, and so on. And then we also, if you remember, looked at the percentages. We had 75% of the gift cards were the $5 cards, and 2.5% were the $100 cards, and so on. They could also be probabilities of mutually exclusive, which are non-overlapping events. We don't need to get too excited about knowing what that is for today. We'll revisit this and we'll study it next spring. And we will talk about relative frequencies as probabilities because they are percentages between 0 and 1, and they can be for things like probabilities of non-overlapping events, which are called mutually exclusive. A histogram itself is a special type of a bar graph that has no spaces between the bars. So it's going to look like a bar graph, but remember when we made the bar graph last time for the gift cards, and we had the bar that represented the $5 cards, and then we had a much shorter bar that represented the $15 cards, and then the other two bars were really, really small, the $50 cards and the $100 cards. All right, those bars had spaces in between here, and our histogram is not going to have any spaces or breaks in the bars. It could have a break in the range of values, and the bar could have no frequency, so it could look like there's space, but that'll be because the frequency is 0. Okay, it's going to break the range of numeric values into intervals of equal width, and that's going to be called the bins. So the width of the bars, will be the bin width. Sometimes the bin width is given to you, and sometimes you have to figure out what you want to use for a bin width. Okay, there are two types of histograms. The first type is a frequency histogram. That's where you display the number of values in each interval. And the other one is the relative frequency histogram, and that, of course, would give you the percent of values in each interval. I'm going to scroll down here so that you can see these two histograms that I have for you. And the book never gives, I don't think it ever gives very good descriptive title. I would give this the title that says this is a distribution of the number of representatives in Congress. Same way on this one. Okay, if we look at the graph on the left, you're going to notice that this says we have frequency right here. Now, we all know that there are 50 states, right? And each state gets so many congressmen. And congressmen or congresswomen, congresspersons are determined by the population in your state. And so we're looking at, in this particular graph, kind of hard to see, so I'll put the tick marks on here. They made a scale that goes from 0 to 24. Nobody has more than, or there were no number of states more than 20 down here in representatives from 0 to 5 that we need to take care of, so they only had to go up to 24 here. And then it's kind of hard to see the little tick marks here, so let me put them on here. They went by 5 for this scale. And they started at 0 and they went to 55. This is the number of representatives for a state, and this is the frequency. So this bar right here, this first bar, has a height of 20. And that tells me that 20 of the 50 states have, and then we have to decide how many representatives we're going to say they have. Well, we want to look up here to this. This tells me that there's a little bar under here, that 0 is included, so starting at 0, going to 5, but 5 is not included. We call this including the left endpoint, but not the right endpoint. Okay, so this would tell me that in this bar right here, this is the number of states that have from 0 to 4 representatives. So they could have 0, 1, 2, 3, or 4 representatives. That would take up 5 place values there. Okay, the next bar has from 5 to 10, so it would be 5 is less than or equal to X is less than 10. So there could be 5, 6, 7, 8, or 9 representatives. And that would be 17 states. Now, how do I know that it's exactly 17? And since it's not on a tick mark, could it be 17.5 or 16.9 or something like that? Well, I'm talking about the number of states, and we can't have a part of a state, so we're going to be able to label these or tell their height, and it'll have to be a whole number, won't it? So the height of the next bar looks to be 5, then 4, then this is 0. There are 0 states that have between 20 and 25 representatives. And this bar looks like it could be 2, and then 1, and then we have 0, 0, 0, and a 1. If I go back and add together 20 plus 17 plus 5 plus 4 plus 2 plus 1 plus 1, I will get an N of 50 because there are 50 states. Okay? And that is the frequency, so it gives you the height of the bars as tally marks for how many states would have that. Kansas, of course, would fall in this first bar because in Kansas we have 4 representatives. So we are in the 0 to 5 category. The question was, are you surprised that the bar from 0 to 5, so 0 but not including 5, and we know nobody has 0, but not including 5, is so tall or is the highest bar? And that probably shouldn't shock us because some states are very small in area, and so they don't have a chance to be very populated. Other states have lots of area, like Montana, but don't have a lot of population, so not going to get very many representatives. The more densely populated states are like your Californias and New Yorks, and those, they're going to get more representatives. Now, if you look over at the next graph, it's relative frequency. So what they did was they took this graph and they changed the scale on it to represent the percent that each one would represent, or the decimal for the percent that each one would represent. So this tall bar right here, which is the 0 to 5 representatives, is still 20 out of 50 states have that, and that would give us 4/10. So this bar has a height of 4/10, doesn't it? The next one, which would be 17 out of 50, because I know the tally mark is 17 over here, would be 3,400. So the height of this bar would be 3,400. The next bar would have 5 out of 50, so it would have 0.1. The next one would be 0.08. This bar would be 0.04, and then 0.02, and 0.02. If we were to add all of these decimals together, the sum of all those decimals would be 1.0. 1.0. So it has the same scale along the x-axis, but the y-axis scale has been changed to reflect relative frequencies. You can see that because they use the same graph paper and the same looking increments here, that the graphs look exactly the same. The only difference between them would be one is representing frequency and one is representing relative frequency. All right. I am going to have you then switch over to your activity page and have you work on this activity for a little bit. I want you to, well, let me get mine up here so you can look at it. We're going to make our own histogram here, all right? And so I'm going to give you a little background about what you're going to make a histogram about. This is the IQs of a random sample of 100 high school seniors, and they're given in this table below. All right, so we don't know where the data comes from, what particular high school, or maybe a mixture of high schools. We just know that they're IQ scores. Let me give you a little background information about IQ scores. I don't know if you've ever been on your computer and it's popped up on a little pop-up thing, oh, take this IQ test and see what your IQ is. It stands for intelligence quotient, And we'll talk some more about it when we learn about the normal curve or the bell curve coming up in another lesson down at the end of this chapter. But an intelligence quotient is going to give your mental age divided by your chronological age. And the IQ test kind of has some roots that started with the military. Back in the times of World War I and World War II, where we didn't have a lot of testing services and testing opportunities like we do now, when the draft was on and we were drafting quite a few people to be in the military, of course, the government wanted to find a way to sort of sort out the people that were going into the Army or the Navy or the Air Force or the Marines, but mostly for the Army. And so they came up with this idea of giving them this IQ test. And then if you scored relatively high on the IQ test, they might put you on track to be, a captain or a colonel or maybe like in a leadership position. But the people who scored lower on the IQs were actually sent out to the front lines to be in the infantry. So it's no big mystery why Forrest Gump and the Bubba Gump shrimp thing came about, because those guys probably didn't have the highest IQs, and they were sent out to do maybe some of the more dangerous work, to be on the front line, because maybe there were going to be a lot of casualties to them. I know it sounds really cruel and really crude that this happened, and certainly we wouldn't do anything like that today. The military is so much more sophisticated, and everything is really technologically done now, so they would use other kinds of measures to see what you might be best suited for in the military. In fact, we have another type of test that people take when they are interested in going into the military called the ASVAB test. And if you're a senior, you might have a chance to take that test before you get out of high school. And what it does is tells you kind of what your aptitude is for different things in the military. So that's just a little FYI about IQs. IQs can range from very, very low numbers to very, very high numbers. You might have heard somewhere down the line that there's a genius, someone like Einstein. He had a very, very high IQ. But you can also have persons with mental disabilities that have very, very low IQs. And so we're going to go ahead and take a little bit of time to enter this data into our calculator. So if you're viewing this together as a class, I'm going to have the teacher stop the video here in just a minute. If not, if you're just doing this by yourself, then you're also going to want to stop this. But does everybody remember how to get into your calculator and enter a list? Remember, we're going to hit our Stat button, and then we're going to go where from there? Let me pull my calculator up and see. We're going to go to Stat, and then we're going to go to Edit, aren't we? Okay, Stat and Edit. Now, when you get to Stat and Edit, if you have something in your calculator that you don't need to use anymore, an old list, and you want to clear that out of there, that might not be a bad idea. So, let me see if we can remember how to do that. We'll go to Stat, we'll go to Edit. Remember, you go up arrow and jump up on List 1, and you want to clear that out. Now, I want to be careful about what you're doing here. You want to go into one list, and you want to put all of these numbers. So it would be a good idea for you to type these and go down this column and then start this column, but you'll put them all in List 1. So you'll have 100 numbers in List 1. You won't start a new list for each one. 100 numbers in List 1 when you get done. You'll want to go ahead when you get finished and run the one variable stats for the list. I'm going to write my numbers on here for what you should get when you do get the one variable stats finished, so that you can know if you're right or not. If you don't get what we all agree on for the sum and the mean and so on, then that means you'll need to go back through your list and check all of your numbers and make sure that you have them correct. Okay, you probably want to pause the video now. Okay, if you've gotten everything done, these are the numbers that you should have come up with. The sum should be 10,032 IQ points. the mean would be 100.32, so 100 and 3200 IQ points. The median would be 100 IQ points. And the range, remember to find the range, we're going to do the high minus the low, and that's going to give us 78 IQ points. All right, if you have all those numbers matching, then you entered everything correctly. If you don't have those numbers matching, you're going to want to pause the video again, and you're going to want to find your mistakes so that you can match up with those. Or if you're doing this as a class, you're going to want to pause the video until everyone has that information. So pause it now if everybody didn't get that. Okay, now after we get our data and we have it all correct, we're going to go ahead and sort this data in ascending order, which means we're going to sort it from least to greatest. Now we don't want to do that until everybody has the same data or has these numbers right here, because once you sort them, then you can't go back and unsort them or put them back in the order that they came, and it would be really miserably hard to figure out where your mistake is. How we sort the data is another little feature on your graphing calculator that you can do. And it works like this. If you go into your Stat and your Edit menu, you're going to notice that number 2 says Sort A and number 3 says Sort D. Sort A stands for sort in ascending order, and Sort D stands for sort in descending order. You're going to choose number 2, or you can use your down arrow and select number 2. We want to get number 2 here. And then the cursor is just sitting there blinking, and it's waiting because it's wanting you to put in there which list that you want sorted. So if your data is in list 1, you're going to go ahead and go second, L1, and select that, put a parenthesis on the end. And then you're going to notice that nothing really happens except maybe you saw a little line right there, and it's going to tell you that it's done. And if you want to see that it's done, you're going to go to Stat and Edit, and then you'll notice now you can tell which one's the lowest and which one's the highest. That would be something that you would want to do if you were trying to determine sort of the range of values. And in your book, when you read this lesson, it's going to talk to you about what to do with that range of values if you're deciding how many bars that you want to make on your histogram. All right, well, we're going to follow some more specific directions over here that say that we want to make a histogram on our calculator with a bin width of 10. So even though we could put the histogram together many different ways, we're talking about doing a bin width of 10. So when we get our bars on here, I'm just drawing a picture here, the width of each of these is going to take up 10 IQ points, and then 10 more IQ points, and then 10 more IQ points, and so on. So we really want to examine these numbers, and we want to figure out, based on our sorted data, what the X minimum value would be and what the X maximum value would be. Now we could start at 66 and go to 144, and we could go by 10, so that means we'd have 66, 67, 68, 69, 70, 71, 72, 73, and 74, and 75. So we could have 66 through 75 be one bin, and then we could have 76 through 85 be another bin, and so on. But a more common way of looking at IQ scores is to look at them from, let's say, 50 to 60, 60 to 70, 70 to 80, and so on, to use a number that ends in a 0. If we did that, in order to get all of our numbers in the 60s in there, we'd have to back this down to 60. And then in order to ensure that we get all of the 140s in here, our maximum value would have to go to 150. Okay? Then the X scale right here, make yourself a note. This is the bin width. That's how we're going to know what the width of the bins are going to be. We're going to say go in increments of 10. Go in increments of 10. Okay, now the next thing it says that we're supposed to do here is we're supposed to go ahead and graph this histogram down here on this piece of graph paper, but we want to graph it on our calculator first so that we can see it. I'm going to move some things out of the way here. We want to be able to see that. On the calculator, and then we'll put it over onto our piece of graph paper. All right? So I'm going to show you how to do that. What we're going to do first, since we have our list here, is we're going to go to our window and set up our window. Now we already know that, let me do this, we already know that we're going to start on 60 and we want to go to 150 and we want to go by 10. That's what we know. For the rest of the window, we need to decide how tall we think the bars are going to be based on the data we had here. Now, you might have been typing in a lot of numbers in the 90s and the hundreds and maybe the teens, 110, 112, and whatever, because that's where the concentration of numbers is going to fall. The average IQ score is normed to be around 100. So you're going to get a lot of scores that are between maybe about 85 and 115, somewhere in there. So you need to kind of lump this off and say, well, we had 100 scores. I don't know how tall to make the bars, but I think the frequency in the 100s, the 90s, the 100s, and the 110s might be pretty tall. All right? So I'm picking 60 for my X min and 150 for my X max, and my scale is my bin width. Remember that. And then this is set on 50. I don't think we need to go clear up as high as 50. We might be able to get by with, let's say, we'll say 30. Okay? And then for Y scale, you're just picking the increments or the amount of space in between the tick marks on the Y. 5 would work very well. Okay, the next thing we're going to do is we're going to try to graph this. So if you go to your Y equals, if you have anything in your Y equals, I want you to get rid of it. Like if you had X plus 6, like a line or something in there, I want you to clear that out of there. Don't keep anything in your Y equals, because we don't want anything else to get graphed on top of our histogram. Now you're going to notice on top of the Y equals key, there's the blue letters that say stat plot. That's how we're going to plot statistics. So if you go to second Y equals, it'll take you into the stat plot. And then you're going to notice that all of these say off, 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 and so on. Okay? That's because we need to turn those features on our calculator so that we can graph with that. So what we're going to do is we're going to take this number 1 and we're going to hit enter. And do you see how your cursor is blinking on the word on? Then you want to go ahead and hit enter to select that. Then you're going to come down with your down arrow to the word type, and you'll notice there's a scatter plot and there's a box and list and so on. You want to come over to this one because it looks like a histogram. And that's what you want to select. So we're going to select that histogram. And then if your list is in list 1, you want to make sure that list 1 is selected. If your list is in another list, then select that. Or if it's something different on your screen and you want to change it, you come down here and you type second L1. Okay? Now, we've got this all set up. Got our window all set up. Whoops. Don't want that. Got our window all set up. So our stat plots are turned on. We're ready to go with those. Our window is good to go. All we have to do is hit graph. And magically, it's going to make our little histogram. Now, I'm going to do this with my window, and you just watch this. Let's say I thought the frequency was 20. I didn't think any bar was going to be bigger than 20. Can you notice that that's not tall enough up here? You can see that. And so you'd want to adjust that window. 30 was just barely tall enough. So I'm going to change this to 35, just because I like to have room at the top and room at the bottom. Okay, now I'm going to hit my trace button. And you're going to see a couple things come up on the trace here. First of all, you're going to see where it says min is equal to 60 and max is equal to less than 70. That tells me that my score is going to fall in between 60 and 70, and it's going to include the left endpoint of 60 but not include the right endpoint of 70. So that first bar would represent the IQ scores of 60, 61, 62, 63, 64, 65, 66, 67, 68, and 69, and that would be 10 IQ points. Another thing you're going to notice over here is it says n is equal to 2 with the cursor blinking right there. That means the height of that bar is 2. Its frequency is 2. If I hit my right arrow and I move along, I have a bar that's now 5. Then I have a bar that's 16 tick marks tall, and then 22, 30, 16, 7, 1, and 1. If I add all those n values together, I should get 100 because this should account for all 100 pieces of my data. Okay, now we want to get this transferred over onto this piece of graph paper here. And so when I'm looking at my graph paper, I'm thinking, well, my tallest bar was 30, so I might be able to go by 2s over here. So let's see. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Oh, my graph paper is just short, so I can't go by 2s. Well, my other options are I could probably go by 3s. My window is set up to go by 5, so if you like that, we could do 5. Back to my graph. Let's do 5. Okay, and what does this stand for? I'm going to write my label on here. This is the frequency. Okay, that's the frequency. Now my x-axis is going to be for my bin width. Okay? Now I want you to put a little jagged line right there because we're not going to start at an IQ of 0. We're going to start with an IQ of 60. And then we can make each tick mark be with 10. Uh-oh. Hang on. I'll stay in class activity, my calculator. Okay. Okay. This stands for Okay, hang on. Everybody hang on. I have so many screens open I can't get my pen to write. Okay, it's underneath here. There we go. Okay. This stands for the IQ score. Okay. And now we just need to transfer the information from the calculator over to okay, now why won't my calculator work here? There we go. Oh no. What is going on? I found this graph again. I'm going to go to my stat plot. Something's wrong with my calculator. Oh, it should work. Okay. So I want to make this bar be 2 for its height. The second bar I want to be 5. And so on. You can follow along and do that. Okay. And then a lot of people, when they finish a histogram, they might write the numbers on the top of the bars for how much there is. It probably wouldn't be a huge deal if you did or did not do that either way, because we know that we have a whole number of frequencies. We have 100 students, so we should be able to figure it out, kind of like that problem we did with the Congress people. And some people like to shade the bars in. That's okay with me if you do that too. There are 2 things that we also need to add to this graph. One of them is the source. And I didn't give you very good information about the source because I didn't have very good information about the source. We don't really know where this came from or what it's about, so we're just going to put the source as unknown. We know a few things about where the data came from, but not enough to make a reference to the source. The other thing is we need to make a title. Now normally I would scroll right up and get on the white part up here, but I don't really have room to do that on this, and I'll lose the rest of my display, so I'm just going to write it on my graph paper here. It's the distribution, and then of what? Well, let's be very, very specific since we don't have a very good source. So it's a distribution of IQ scores. Okay, it's from a random sample. And a random sample of what? Well, 100 high school seniors, right? So they're not first graders, they're not adults, they're high school seniors. It's random. I don't know if they were chosen randomly at one school or randomly off the street or what, but it's 100 and it was random. Now, one more thing that you could put on a histogram to help it is sometimes you put a legend on here. In this case, it would be n equals 100. You could write it here or down in the white part or off the graph. I just stuck it right here. But this helps tell me that if I were to do all these bars, the heights of them, the frequencies of them, I would need to get 100. I also put that in the title, which is pretty nice. Okay, now let's talk about some intervals over here, how we're going to write the intervals. Okay, we want to know which interval has the greatest frequency. Well, if we're looking at our picture over here, the interval that has the greatest frequency is this bar right here, isn't it? It's the one that's the tallest. And that's the bar that goes from 100 to 110. Whenever we write intervals, we don't just write 100 to 110. Because that doesn't tell me if I'm including 100, not including 100, am I including 110, not including 110, and so on. So I'm going to write all my intervals using notation with inequality symbols. So I'm going to say x is less than on both sides of it, and I'm going to put a bar under this one, so less than or equal to x is less than. This is going to include the left endpoint but not the right. And then I'll put my 100 IQ points here and 110 IQ points here. So x would lie between 100 and 110 IQ points, including 100, but not including 110. Now, the next one says, can you find the interval that contains the median value? Well, we can kind of cheat on that a little bit because I had you do the one variable sets, and you know the median because we had the whole set of data. The median is 100. 100 would fall in this same bar that I shaded in over here, wouldn't it? Now, if you didn't know the whole set of data, you would have to find the 50th and 51st pieces of data, and then halfway between those would be your median. So another way you could find it would be to go back to your calculator and add this up. We have 2 plus 5 is 7, plus 16 is 23, plus 22 is 45, so I have 45 pieces of data so far. And so in the next bar, because it contains 30 pieces of data, it would be the 50th and 51st pieces of data would lie in that bar. So we're going to write that interval as x, less than signs around it. It's going to include the 100 IQ points on the left, and then is less than 110 IQ points on the right. Okay, the interval with the lowest IQ in it is between 60 and 70. It's this interval right here. So we would say 60 IQ points is less than or equal to x is less than 70 IQ points. And then the highest IQ lies between 140 and 150. So we would say 140 IQ points is less than or equal to x is less than 150 IQ points. Okay? On your homework for today, you're going to be asked to write some intervals. It could be degrees if you're in temperatures. It could be percentages. It could be, hundreds of barrels of oil. It could be whatever, but you want to make sure that you label them and that you write them this way. You have a good model. If you get this written down, you have an excellent model of the graph of the histogram with all the parts on it and how to write the intervals. Okay, it says the last thing you should do is make your histogram have a bin width of 15. So if you start monkeying around with it here and you change it so the bin width is 15, that's going to compress the graph into fewer bars. So the frequency of the bars, of some of the bars anyway, is going to get larger. And so if I just go ahead and hit graph, it'll change my frequency, change the frequencies and recount everything for me and put it in groups of 15 for each of those IQ points on the bin width. But you'll notice that now my graph's not tall enough. So I might need to increase this to, like, let's say 50 and then here would be my picture. And so again, if I hit my trace button and I move along here, all those ends added together have to eventually add up to 100. I didn't lose anybody, I just compressed my graph and I made it look a little bit different. Okay? I'm going to take it back to 10 so I can use it for something else a little bit later. Okay, now let's go back to your back to my lesson that I was working on with you, and I want to work with you on a note card. So we'll do a little note card, and let's write down the things that we did in order to make a histogram. Okay, so we can call this 1.3 histograms. We might want to put the definition on here. It's a bar graph with no spaces between the bars. No spaces between the bars. Okay, so we're going to write down the order of the buttons that we pushed on our calculator. Okay, I first had you go to the Stat menu, and in Stat, we had to go to number 1, which says Edit, and then we had to hit Enter, right? And then we had to type the data in a list. It could be list 1 if you want to use list 1. It could be list 2, whichever list you want to do. Okay? Now, I had you, after that, go back to Stat and use your right arrow and go to Calculate and do the one variable stat, didn't I? The reason I had you do that was so, for one, we could check with each other and make sure we had all of the stuff just right. What list one? All of the stuff so that we all agreed on it. The reason why you would want to do that on your own is not for checking, because you don't have anybody to check with, but would be so that you could look at the range of values and try to figure out how many bars you want and how you want to set up your histogram. So those statistics that are in one variable stats could help you do that. Okay, then let's talk about how to make the histogram. To make it, I had you go to your second key, and then I had you go to the Y equals button. Second Y equals, because remember above that it said stat plot in blue. The stat plots were above that. And then you picked number 1, which said plot 1 ... And then we hit enter. So we went into the stat plots, and then once we were in there, you told the calculator, turn that on, okay, you turn that on, and then under type, you pick the picture that looks like a histogram. So we had that little picture of that little histogram, remember that? You picked that, and let's see, what else did we do? Oh, on the X list, we want to make sure that this says L1 if you're using L1. It needs to say L2 if your data was in L2. So you could pick all of those kinds of things. Okay? So that's how we're going to do the work on the stat plot part of it. Okay? Then you need to go to your window, the button that says window, and let's set up your window. You're going to have an X min and an X max and an X scale, aren't you? Okay? We know that the X scale is the bin width. The X scale is the bin width, isn't it? Okay? I'm going to run out of room here. I'll have to put it here. Okay? You have a, whoopsie. You have a Y min, a Y max, and a Y scale. Okay, all of these things have to do with your frequency. Okay, your frequency. So you're going to look at that and you're going to try to figure out, well, how tall are those things and what do I want for the scale on my frequency? Do I want to go by 5s or by 1s or whatever? That has to do with your frequency. Your X-min and your X-max are going to be your borders, your boundaries for how low you want to start and how high you want to go. Remember, we went from 60 to 150 for our people with the IQ scores. After you get your window set up, you should be able to just do the graph button. And then if you want to see what you just did, you do the trace button. And that'll help you see the frequencies and how tall each of the bars is. All right? So that might help you remember what to do. It's a little tricky when you're first working with stat plots. I want to show you something else on your calculator. If you were to go now and try to graph something in your y equals, do you see how the word stat plot or plot 1 up there is darkened? Well, that's because we have that turned on. And if you wanted to go back and do any regular algebra with your calculator, you would need to push your up arrow and jump up on there and turn that off. Or you could go back to second stat plot and you could turn it off that way. You could go in here and you could highlight off and you could turn it off. So that's just a little FYI that when you're working with stat plots and you have them turned on, then you might want to turn them back off so that you can do maybe the review questions for your homework. Okay, so I want you to take that last empty blank note card that you have, or if you need another note card, get one off my desk or get one from the substitute, and then we're going to make another note card that has a checklist for everything you need for a complete display. Complete display. And here's the things that you need. You need the accurate, descriptive title that begins with distribution of. We're going to be distributing some kind of data. You need your axis or your axes drawn with a ruler in equal increments. Equal increments. That means that if I have equal increments, if I start and I say this is 200, and I say that this is 0, and I say this is 210, those are not equal increments because this distance from here to here is 200, and this distance from here to here is the same distance on a ruler, but it's only 10. So we want to make sure we have equal increments. You want to label your axis or your axes. For the histogram and the bar graph, we have an X and a Y axis, but something like a box and whisker or a dot plot or a stem and leaf, something like that, isn't going to have two axes, is it? You want to accurately draw your display. After it's accurately drawn, you want to list the source, or if there is no source, you're going to put source unknown, so we'll know that it was not necessarily from somewhere that was reliable. And then the legend, if necessary. Remember on the histogram we did the n equals 101. If you had a stem and leaf plot, you might put your legend 2 bar 7 represents 27 CD, something like that could be your legend. Okay? So take a minute and write those down. You can pause this video if you need to, but you want to get that complete checklist on there. The reason is I want to make sure that you have all of those parts every time you make a display. I've been modeling that for you. We did that last time with the gift card problem when we made the display, and we just did that when we made our histogram just a minute ago for the IQ scores. So you have good models to go with. You don't want to forget any of these parts. I will not be very forgiving if I'm telling you to put all this on your display and then you're not putting the title on or you're not putting the source on, those kinds of things. Okay. If you need to pause the video, and then we'll meet back here to talk about the next part, which is going to be on analyzing the histogram. When we analyze a histogram, we analyze it by its shape. It could be skewed. Okay, skewed means that it's going to be bunched up with frequency to the right or to the left of the center, either to the right or to the left, and that would be of the center. Okay. We also have symmetric graphs where the sides are approximately the same shape. They don't have to be exact because we're working with raw data, but they need to be approximately the same shape. So we ask ourselves these questions. Is the distribution skewed? Does the distribution have a tail? If so, at what end is the tail? And is the distribution symmetric? It's just best to look at some pictures and then we can determine this from looking at our little pictures here. Okay, this first graph, which of course came from the book and doesn't have a title, is something about temperatures. They must have been counting how many temperatures were between, let's say, 20 and 30, 30 and 40, and so on. What I like to do is I like to think of, if I were to put a curve on here, and kind of curve around here, Would my data have a tail on it? And in this case, yes, it has kind of a tail. It has a tail to the left. So it has a left tail, which means it's skewed to the right. And then what does this mean if it's skewed to the right? It means that we have the concentration of the data is in the higher temperatures. The concentration of the data is in the higher temperatures. So we have more higher temperatures than we do lower temperatures. The data is not symmetric, it is skewed to the right. Now if I do the same thing for this next problem, this one kind of has a right tail on it. It has a right tail on it. Alright, if it's got a right tail, that means the data must be skewed to the left. That means the concentration of the data, this is about number of siblings, means that more people, whoever they surveyed and they asked them how many siblings do you have, more people had fewer siblings than a whole bunch of siblings. Like this family, if you have 7 siblings, there's 8 children in your family. If you have 5 siblings, there's 6 children in your family. If you have 0 siblings, you're the only person in your family. You're the only child. So we have more data on the left, meaning more people that were surveyed had fewer siblings than more siblings. And then this display, I kind of lump it off here, looks like it's pretty wet. Symmetric. Not exactly symmetric. I can't fold it exactly in half on this line that goes down through here, but it would almost match up if I did. Okay? So that data is pretty well centered around the interval, which would have the median in it, wouldn't it? Okay? So it's kind of centered around the 400 is less than or equal to X is less than 410, and I didn't put my labels on there, customers. Okay, put the customers on here. Okay, so that's the long and the short of histograms. Does that mean you don't need to read the lesson? Absolutely, it does not mean that. It means you definitely need to read the lesson. If you don't have Lesson Master 1.3 in your hand right now, then pause the video and get a copy of Lesson Master 1.3. If you do, I'm going to switch over to that and I'm going to talk to you about a couple of problems on Lesson Master 1.3. On Lesson Master 1.3, you could probably guess by looking through it that you're going to have to do 3 histograms. How do I know this? Because there is a piece of graph paper on the first problem on Lesson Master 1.3, and there's 2 more chunks of graph paper over on the third page for problems 3A and 11A. I'm going to provide you with the graph paper so that you can make the displays look really, really nice. Okay, I want to talk to you just a little bit about this first problem about the 36 pennies. On the problem with the 36 pennies, the date that the pennies were minted is what you are going to be looking at. So somebody had some pennies in a jar and they poured them out, and this is the mint date. And the one that was minted the earliest in the jar is the one from 1971. The one that was minted the last or the latest in the jar was, I think maybe somebody said there was a 2005, or is there a 2006? I think there's a 2005 penny. Okay? They want us to use a bin width of 5 years. So your lowest number is 1971 and your highest number is 2005. And they've already decided they want us to do 5 years. So if you did 1971, 72, 73, 74, and 75, that would take up 5 years. And then you could go on to the next one, which would be 76, 77, 78, 79, and 80. That would be another 5 years. If you followed that pattern, eventually you would get up to 2001, 2002, 2003, 2004, and 2005, and then it would end right there on that one. So I think that would be the best way to strategize this, is to have this be your X min, have this be your X max, and then your X scale will be this 5 years. And that way, You don't have to go clear back to 1970, and you don't have to go forward. If you had to go forward, if you didn't get 2005 in there, you'd have to go with a whole nother bar. But I think that will fit nicely on this little chunk of graph paper that you have over here. Okay. I also wanted to mention to you that when you work on this, you're going to have a label on lots and lots of things. And then you're going to notice when you get down to number 6, it's talking about intervals. They need to be labeled as well, but you'll look at your worksheet that you did over on the in-class activity, and you'll be able to remember how to write those intervals. Okay, I think you're going to be pretty good to go on this. I will mention that the last page of your packet is a practice quiz. I gave that to you so that you could practice all the problems from lesson 1.1 through 1.3. That would be the most important things to know for your quiz. I think you need to go back and read the book before you start. I would do the book work in the vocabulary, then I would come back and I would do the lesson master. Page 2 of the lesson master is a page that I like to call redemption, because on that page you will find that there is another table for you to work on with some numbers, and I'm expecting you to do much better on that table with those numbers than you did in the past. If you're still having trouble with that, you need to get in to see me about that, because we had some major difficulties on that on our homework from lesson 1.1. Which now brings me to lesson master 1.2. I'm going to go ahead and use some remaining time here to talk to you a little bit about lesson master 1.2, because there were lots of concerns about the questions on this, and I want to make sure that you get a fair shot at looking at those like the other classes did. I'm going to start with problem number 3. Problem number 3 is like problem number 11 on the back, and I'm going to go ahead and label this because on the back side of the lesson master they asked you to take some variables and put on here. They said that let x sub I be the cost and w sub I be the shares. X sub I is the cost and w sub I is the shares. Okay. When you work this problem, you do not just add up all the shares and add up all the cost and then just average them that way. You want the average cost per share. So you can see that these shares would be more heavily weighted than, let's say, these shares, because I'm buying 11,000 of them at $71 a piece versus 5,000 at $49.25 a piece here. This is the price per share. So in this one transaction, I'm going to be spending 5,000 times $49.25. So this one transaction right here costs $246,250. Okay? So I'm going to have to get all of the money that I spent added together and then divide by the total number of shares. So I want the sum of all the money that I spent divided by the sum of all the shares that I bought. Okay? So let me go over to problem number 11, and we'll talk about, well, I'll just write it on here because I have room. We'll talk about how you could get that in terms of what you did abstractly. Okay? So abstractly, the cost per share, average cost per share, is going to be the sum of all the money that we spent. Okay, well there are 1, 2, 3, 4, 5, 6, 7, 8 transactions, so this is going to say I equals 1 to 8. And then to figure out how much total money we're spending, we have to multiply these together, multiply these together, these together, these together, and so on. We have to do all of our multiplications and then go back and add those amounts together. So I want to multiply the w sub i's times the x sub i's. I'm going to put parentheses around that to show that I would take 5,000 times 49.25 plus 10,000 times 57.50 plus 7,500 times 62.25 plus 6,000 times 82.50, and so on and so on. Okay, I want to get that all added together, and then I want to divide by the total number of shares. Well, The total number of shares would be, again, there were 8 transactions, and they are all of those in this row right here that make up the W sub I. Make up the W sub I. So back on number 11 on the second page, this is abstractly the formula that you would come up with to do this. If you do that, your cost per share, your total amount of money that you spent should eventually come up to $4,363,875, and the total number of shares is 62,500 shares, and you need to get that divided out. And then over here, you'll label it with a $ sign, and it's not going to come out exactly. It's going to be a squiggly line answer. All right? So I want to talk to you about that problem. I had a lot of questions on number 4 also. If you're having trouble with a problem like number 4, my best advice would be to make that little chart like you had on the worksheet that we did together where we had Francis and Adam. Okay? And we only have one student, and her name is Lydia. I'll try to make a little chart here for Lydia. And in Lydia's class, her teacher grades on tests, she grades on homework, she grades on quizzes and classwork, and she grades on a final grade, a final test. Okay? Let's see what percentages she puts with that. Okay? Well, she has an 89 average before the final. An 89 average before the final. So she may not really have 89 in each one of these things, but her average is 89, so we can use 89 here. We don't know what she got on the final because she hasn't taken it yet. Okay? So let's put the weights on here. The tests are weighted at 40%. The homework is weighted at 20%. The quizzes are weighted at 20%, and the final is weighted at 20%. These are like the problem that we did with the relative frequencies when we had the gift cards. If we multiply these together times their relative frequency, because these are written as percentages, then we should be able to just solve the problem and multiply through and solve the problem. So I'm running out of room here, so I'm going to just write it kind of in the margin here. We'll have 89 times 0.4 plus 89 times 0.2 plus 89 times 0.2 plus 0.2x, and we want the new average to come up to 90. Now we can go back and get a number for this, subtract it to the other side, and divide, and we should be able to come up with what her grade could be for that. All right? There were several problems like that on this sheet. Number 5 is kind of like that. You could make another little column right here and put your how much each one of those grades is worth, and then that one we would have to get the sum of all the grade points and divide by the sum of all the hours. Okay? The sum of the hours, so we'd have to divide by the total number of hours because that one is not written as relative frequency. I think that should get you through most of what you needed on the first page of the lesson master. On the second page of the lesson master, people were asking me about number 15. You had your set of 24 integers, had a mean of 38. Now, if you want to, you can get out that note card that we had from lesson 1-2 where we wrote down how to create a list, and I know it's blank on the back, but when you want to find an average, let's think of it in terms of our variables that we have now. You get the sum of everything, you divide by the number of numbers, and that gives you the mean, which is x bar. So if I write it in terms of these variables that we've been using, sigma is the sum, n is the number of numbers, and the x with the bar on it gives you the mean of it. Okay? If we had 24 positive integers with a mean of 38, then that means, I don't know what the sum is, but if I had 24 integers with a mean of 38, if I would cross multiply this, that would give me the total amount that I have right there. The total amount. Okay? And I think that's 912, isn't it? So these 24 positive numbers have a sum of 912. So I have 912. I'm going to add 32 to the set, and now I'm not going to divide by 24 anymore. I'm going to divide by 25. Then that will give me my new mean. So I just kind of need to work these variables. I'll know 2 out of the 3 of them, and I can figure out how to get that mean. Now, about the median, we have to think of this a little bit differently. I had 24 numbers in my set, and here's my first number all the way down to my 24th number. When I had found the median, when I had 24 numbers, I had taken the 12th and the 13th, and I had averaged them together, and I found that mean of those to be 32.5, so that became the median. So whenever I have an even number of data points, I have to average the 2 in the middle together, don't I? Okay, so now what happened is I added 32 to my data set. Well, 32 is less than my median, so that 32 comes in here right above the median, and it slides in and it becomes the 13th number in the set, doesn't it? Because it's going to be fit right in here somewhere, the 13th number in the set. So that's going to push that. Now I have 25 numbers in my set, and 13 is the median. The 13th number in the list would become the median, which makes the new median be 32. The new median would be 32. Okay, I really think that if you had those hints, that you'd be good to go for the rest of this. I think that if you have any extra time now, and you need to finish up lesson 1, 2, you need to do that. Everybody needs to turn that paper in before they leave. I'm going to hold your 1-1 homework because I still want to talk to you about it. If you want to come and pick it up from me sometime Friday, that would be fine if you want to use it to help you with the 1-3 lesson master. But I do want to talk to you about those charts, graphs, and tables a little bit more that we were trying to manipulate, and some of the sentences that you wrote, because we really do need to work on sentences that are true and that make sense and that are complete and that are clear and that are concise. But I want you to go ahead and try those, see what you can do with them, but I will talk to you some more about those in class. As you can see, we're not going to have time to take our homework quiz, so don't worry about that for now. We'll get that homework quiz made up some other time. Remember, you do have a regular quiz the next time we get together. So if you have any concerns on that practice quiz, please let me know.